Hello there. In this lesson, we are going to explore Bohr Rutherford diagrams. Now, if you recall, during our lesson on atomic theory, you learned that Niels Bohr discovered that electrons were found in layers. So that's this guy. That's his contribution. And Ernest Rutherford was the guy who discovered the nucleus with the gold foil experiment. So having a model that includes a nucleus and layers of electrons is called a Bohr Rutherford diagram. And it's really useful when you're learning about physical and chemical properties of different substances on the periodic table. You can start to see patterns and make predictions. So we're going to use the periodic table to determine the number of protons and neutrons and electrons to put into a Bohr Rutherford diagram. We're going to put the protons and the neutrons in the nucleus, and we're going to put the electrons in these layers around the nucleus. And so from our periodic table, you see we have two values. We've got these blue numbers that are in the top corner here, and we have these red numbers with the funny decimals that are in the bottom. So the blue number is your atomic number, and the red one is the mass number. So standard notation for an atom includes both those values that come from the periodic table. What we have here is the atomic number, and here we have the mass number. And then over here we have a charge, if there is one. So we're just going to be dealing with atoms with no charge today, so there won't be any pluses or minuses on this side. But we will have mass number, atomic number, and that's what we're going to use to draw our diagrams. Okay, so not every periodic table is exactly the same. So it's important to note that the atomic number is always just the smallest number of the values that's given on a periodic table. So for sodium, it's 11, and for phosphorus, it's 15, and for fluorine, it's 9. So these are all atomic numbers. And then the larger one that's sometimes a decimal is the mass number. So this is mass number, and mass number, and mass number. And so what you do if you're trying to determine the number of each of the particles is you have to use those two values. So first off, the number of protons is the same as the atomic number. So if we're looking at the first one here, which is sodium, there's going to be 11 protons. The next one here, which is phosphorus, and it's going to be 15 protons. For the last one, which is fluorine, F-L-U-O-R-I-N-E, there you go. Fluorine has 9 protons. The other one is your neutrons, and in order to get that, you need to subtract from the mass number. I see the mass number is this weird decimal, so what you do is just round that off and you get the most common number of neutrons. So 22.9 becomes 23, and 30.97 becomes 31, and 19, of course, is 19. So then you do subtraction, so 23 minus 11 is 12, right? Minus 11 equals 12, and that's your number of neutrons. And 31 minus 15 is 16, and then 19 minus 9 is 10. So now you know the number of both of those particles that goes in the nucleus. And then since we're only doing neutral atoms, there's no charges, no positives or negatives, the number of protons will be the same as the number of electrons. So if we get 11 protons, that's 11 electrons, because the charges have to balance out. 15 protons, 15 electrons, 9 protons, 9 electrons. There you go. You're all set, ready to build your Bohr Rutherford model. Alrighty, to start our Bohr Rutherford diagram, we're going to start with the nucleus. And as we determined earlier, the nucleus is going to have the protons and the neutrons in it. So those two values are going to go in here, and you can draw them with a little p or an n next to them in order to indicate. So for sodium, there was 11 protons, and there was 12 neutrons. And for phosphorus, there was 15 protons and 16 neutrons. And then for fluorine, there was 9 protons and 10 neutrons. Some people use like a little plus and a 0 along with them just to show the charge. I'll leave that up to you. Choose which works best. So the second part of building a Bohr Rutherford diagram is to put on the shell. So in the center here we have our nucleus, and then we're going to put these layers of electrons on around. And we got to find out how many electrons are going to go in each layer. So you can kind of see by drawing it here that there's more space as the layers get further from the nucleus. But since the electrons don't always fill in order, we're just going to do the first 20, which follow a nice easy pattern. And then if you want to learn more, take some more chemistry, and I'll show you how to work out the more complex patterns of electrons after that. So for the first 4 shells, which is all we're going to use for grade 9, you're going to put 2 electrons in that first layer. So you can put like 1, 2, the first layer. Now if you need to go to the second layer, there's space for 8 there. So you got 1, 2, 3, 4, 5, 6, 7, 8. The third layer can also hold 8. Actually holds more than 8, but we only need 8 for the first 20. So you can do the same thing as you did for the second layer. Now you notice I'm putting them on sort of do the 4 corners first, sort of do like compass points, like north, south, east, west. So put them on like that. It'll help you later on. And our last layer, in order to get to 20, we have 18 so far here. So 19 and 20 will go on the last layer there. So depending on the number of electrons, you will just follow that pattern, 2, 8, 8, 2, and you'll have the right number of electrons in each shell. Alrighty, so let's put it all together. Recall that for the shells, we've got 2, 8, 8, 2 as the pattern for filling them up. And let's go. So for sodium here, we'll draw ourselves a nucleus, and we'll put our 11 protons from the atomic number and our 12 neutrons from our subtraction. And now to make this a neutral atom, we are going to have 11 electrons. So shell number 1 is going to get 1, 2. And shell number 2 gets 3, 4, 5, 6, 7, 8, 9, 10. Almost there, need one more. Shell number 3, 11. There you go. Bohr Rutherford diagram for sodium. Phosphorus. We got 15 protons and 16 neutrons. That means we need 15 electrons to balance that out. So shell number 1, 1, 2. Shell number 2, 1, 2, 3, 4, 5, 6, 7, 8. We're up to 10. Shell number 3, last 5, 11, 12, 13, 14, 15. There you go. Bohr Rutherford diagram for phosphorus. Last one here, fluorine. This time we have 9 protons, and 19 minus 9 is 10 neutrons. So layer number 1 has the first 2 electrons. Layer number 2, 3, 4, 5, 6, 7, 8, 9. There you go. Bohr Rutherford diagrams for 3 elements. So it turns out that the outer shell of electrons is where most of the action happens when it comes to bonding or determining physical and chemical properties. So it gets its own name. They're called valence electrons. And so it's pretty easy once you know what you're looking for. Just look at the outer shell of electrons. You can see that sodium has 1 valence electron. And you can see that phosphorus has 2, 3, 4, 5 valence electrons. And you can see that fluorine has 2, 4, 6, 7 valence electrons. And so being able to quickly discern that will be helpful later on as we start to bond these atoms together. Sometimes it'll only be necessary to have the valence electrons, not an entire Bohr Rutherford diagram. And so a Lewis dot symbol, that's what it is. It's just the symbol of the element with the valence electrons arranged around the outside. Just be sure to follow that same pattern of putting them on sort of like compass points, and you'll have a nice Lewis dot symbol. So for sodium, there's only 1 electron, so you can put it like top center. Phosphorus had 5, so 1, 2, 3, 4, 5, like so. And fluorine had 7, so 1, 2, 3, 4, 5, 6, 7. So there you go, Lewis dot symbols. They're going to be really useful as we go along. All right, so finally, using your periodic table, you can take some shortcuts to various aspects of the Bohr Rutherford diagram. The group number, or the column number, will give you the number of valence electrons. So you see that sodium here is in group number 1, and it has 1 valence electrons. Calcium is in group number 2, and it has 2 valence electrons, right? Group number 2. You have to sort of skip this in-between section and like just knock off the first number, the last bit here, and then it'll follow the same pattern on the other end of the periodic table. So 3, 4, 5, 6, 7, 8 valence electrons. So fluorine is in group number 7, according to this pattern, and you've got 2, 4, 6, 7 valence electrons. With the periods, that's what tells you how many layers of electrons you're going to have. So you can see sodium is in the 3rd layer, and it has 1, 2, 3 layers of electrons. And you see calcium is in the 4th layer, and it has 1, 2, 3, 4 layers of electrons. And fluorine is up here, it's in the 2nd layer, and it has 1, 2 layers of electrons. So there you go, so a few shortcuts are a way to double check your work once you're done making your Bohr Rutherford diagram. Okay, talk to you soon.